Here we're going to do a quick review of functions. For example, if I have f of x is equal to x squared plus 5, how would I find, say, f of 3? Okay. What's important to remember in a function notation is this is really like f of box would be equal to box squared plus 5. So f of x is equal to x squared plus 5. So I'm going to make just a bunch of these here. Alright, so say I wanted to find f of 3. What that means is everywhere I see an x, I'm going to put a 3. So 3 squared plus 5 is going to be equal to 9 plus 4 is 14. I'll go ahead and write that out just to make sure we're all on the same page. Okay. If I want to find x of 2, or f of 2, again, looking at this original equation, it's 2 squared plus 5. So 4 plus 5 is 9. Now, 0 is pretty straightforward as well. Plug in a 0. 0 squared is 0, plus 5 is 5. Where this can get a little bit more complicated is if I plug in a negative number. So let's try negative 3. f of negative 3, I'm putting it in a box. If you're doing it algebraically, you think about putting it in parentheses. So that whole negative 3 is going to be squared. Negative 3 times negative 3 is positive 9. Okay? And this is pretty much the worst thing that can happen is they give you a negative number. So it's in the box. The whole thing is squared. Think about it also as being in parentheses. Negative 1 squared is positive 1 plus 5 is 6. So you can get negative f of negative 6. Think about it how you do it up here. It's f of negative 6 is negative 6 squared. Everywhere I see an x, I put in a negative 6. So negative 6 squared is 36 plus 5 is 41. Okay, so that's function notation. We can do this with rational functions as well. So, and again, a rational just means a fraction. So if I had something like this, x plus 6 over 2x minus 3. That's pretty good. I don't know if that's infinitely prettier. So if this was my new function, if I wanted to find, say, f of 1, then that means that everywhere I see an x, I put a 1. So if you even want to kind of set it up with little boxes or two, you can set it up like this if it makes sense for you. And say, okay, everywhere I see a box, I put a 1. So 1 and 1. So I could say 1 plus 6 is 7 over 2 minus 3, or 7 over negative 1. Or you could say, or just think about it without the boxes, and say, okay, so negative 1, so looking at this, everywhere I see an x, I put in a 1. 1 plus 6. 2 times 1 minus 3, and again, you get the same thing. It's just a different way of picturing it in your head, and any way works for me. I don't really care how you get the answer as long as you get it legitimately, and that it makes sense to you. Alright, so let's try f of 3. For f of 3, everywhere I see an x, I'm going to put a 3. So x plus 6 becomes 3 plus 6. 2x minus 3 becomes 2 times 3 minus 3. So I get 9 for 6 minus 3, or 9 thirds, or 3. Again, trying to put in a negative number just to make sure we're cool with it. Pull down a little bit. Alright, so again, everywhere I see an x, I'm going to put in a negative 2. So x plus 6 becomes negative 2 plus 6. 2x minus 3 becomes 2 times negative 2. 2x minus 3. So I've got 4 over this, which is negative 4/7.